So today we are building on what we talked about yesterday with the counting principle, and we are going to talk about permutations. Has anyone ever heard this word? Permutations? Okay, so here's how I would want you to remember permutations, okay? Most of you have a lock on your locker, yes? When you go back to your locker, you're going to put in your combination, 27, 14, 30. Okay? Now, would that work if you put in 27, 30, 14? No, it has to be in the correct order, okay? So, in the math world, we would not call this a locker combination. We would call this a locker permutation, okay? A permutation is an arrangement in which the order matters, okay? The order of our elements is very, very important, okay? We're going to talk about combinations when we get back from spring break. In that case, the order does not matter. Okay? So, if I want to find the permutations of the letters A, B, and C, that means I want all the possible arrangements, and the order does matter. So, you see the list on your page, right? We could start listing them out. A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. How many are there? 6. How could we have found that using the fundamental counting principle from yesterday? No, not quite. Okay, and what do we call that? 3 factorial. 3 times 2 times 1. Okay? 6 permutations of the 3 letters, and we could get that by doing 3 times 2 times 1 or 3 factorial. Okay? This is not written on your paper, so make sure you're following along and writing down what you need to write. Three letters, the number of arrangements of all the letters would be 3 factorial, or 3 times 2 times 1. All right, now, what if we have 4 letters, A, B, C, D, and instead of picking all of the letters, I just want to know how many permutations there are when I select 2 of them. If I select just 2 of them, I would want to write it out very organized, okay? But instead of writing that list, how could I do this mathematically?
4 factorial divided by 2?
Not quite. How many do we have up there? 12. Why would it be 4 times 3? Yeah, there's 2 slots, right? How many letters are possible for the first slot? 4. If we pick out of the hat, how many possibilities do we have for the first slot? 4. Now that we've picked one, how many possibilities are there for the next slot? 3. So it's just 4 times 3. Okay? We're starting off with 4 letters, right? If I pick 1, how many different ways are there to pick 1 letter? 4, right? Because if I have 4 in a hat, I could pick any of those 4, right? After I pick that one, I keep it out. So how many are left in the hat to choose from? 3. So we've picked another one. So that's 4 times 3. And we only want 2 letters, so that's why we stop at 4 times 3. Okay? All right. So when we want all the elements arranged, that's always going to be factorial. If we want all the elements arranged. For example, the number of permutations of 4 different things taken 4 at a time. If I have 4 books and I want to arrange all 4 of them. If I have 4 people and I want to put them in a line. Okay, that's going to be 4 factorial. The other way we can write that. Thank you. Okay? Sorry. I'm just going to leave it at that for now. That's okay? So, in general, that was just with 4. So, in general, if we arrange n things, taken n at a time, then it will be n factorial. All right, so in general, number of permutations of different things taken n at a time is n factorial. So let's try this next example. 5 different books are on a shelf. In how many different ways can we arrange them? How would we do that? 5 factorial. We're arranging all 5. So 5 times 4 times 3 times 2 times 1, or 5 factorial. Now, is your answer 5 factorial? No. What's your answer? 120. Okay? The factorial is how you get to your answer. It's not your actual answer. All right? Look at the next one. This time it tells us that there are 6 factorial permutations of the 6 letters in the word square. Would you agree with that? 6 letters, we can arrange them 6 factorial different ways. Now, in how many of those ways is R the second letter? So I want you to think about this for a second. Try not to call it out. Think about what this might look like. What do you think? 120. How'd you get that?
Because it has to stay in the same spot, so you took off the 6 from the factorial. You just moved down to 5.
Okay. So if R, it has to be in this spot right here. How many other letters do we have to arrange? 5. And how many different ways can we arrange those 5 letters? 120, and we do that by doing 5 factorial. Okay? Oopsies. All right? Before we go on to the B, what if R was in the last spot? How many ways would there be to arrange it? The same thing. What if S had to be in the 4th spot? Still 120. Yeah. Huh? No, just S by itself. Anytime we had one restriction on this, how many letters are we left with? 5. So there's 5 factorial arrangements of them. Okay, next one to think about. In how many of them are Q and E next to each other? Now, R doesn't have any restriction anymore. The only thing we're thinking about is how many are Q and E next to each other. So, let's think about this. We want to write out all the different possible places that Q and E could go. So how many total spots are there? 6. So go ahead and draw out your 6 spots.
Is R still going to be the second one? Or
No, we don't have any restrictions on R anymore. Just Q and E being next to each other. All right? So let's go ahead and let's pretend that we're going to put Q, then E. Okay? How many letters are left to arrange in these 4 spots? 4. And how many different arrangements are there of those 4 letters? Okay, and how'd you get 24? 4 factorial. So I'm going to write this. There are 4 factorial arrangements of these last 4 spots, right? But is that all my options? Are there 4 factorial ways to do this? No, because what could I do with Q and E? You can move them over, right? And then at the end, we could think about flipping them. So I could have Q and E in the first 2 spots, and then how many options were there? 4 factorial. What if I move Q and E to the next 2 spots? Then there's 4 factorial there. What if I move Q and E here? There's 4 factorial options there. 4 factorial options here, and 4 factorial options here. So how many arrangements are there right now? How many different total arrangements of the letters are there right now? How would I find it? What would I multiply?
24 times 5.
Okay. How many different arrangements of 4 factorial do I have? There are 5 here. 1, 2, 3, 4, 5. So this is 5 times 4 factorial. Are these all the possibilities? Do you have a question? Are you trying to give the answer? Okay, hold on just a second. Are these all the possibilities with Q and E next to each other? No, why not? Yeah, we can flip them. So if I flip Q and E, what does that do to my total number of arrangements? It doubles it. So this is now 5 times 4 factorial times 2. This is how we're going to come up with our final answer. Adam, go ahead. Okay, cool. Okay. All right. And what do we get when we do 5 times 4 factorial times 2? 240. Catherine, question.
I understand the double part. I just don't understand the part before it where it's like you move, every time you move it's a 4.
4 factorial. So no matter where I place Q and E, there are 4 factorial ways to arrange all the leftover letters. Okay? There are 5 ways that I can place Q and E in my setup. The first 2 spots, the next 2, the next 2, and the next 2. That's what those little rings represented. Were the 5 ways that I could put Q and E there.
Oh, okay, I get it.
Does that make sense?
Yeah.
All right, cool. Okay, any other questions about that? All right, so earlier we had A, B, C, D, and we only wanted to choose 2 letters. We arranged 2 letters. And we found out that we had 12 permutations of them. 4 times 3. Okay? So if I am choosing 2 letters from 4, the way I'm going to write that, it's in pink right here, it's kind of hard to see, is little 4, big P, little 2. These are subscripts. These are numbers written like below the letter. So the first number, that 4, represents the total number of things we have to choose from. The 4 letters we're choosing from. The smaller number, 2, represents how many of them we are choosing. Okay? Now, mathematically, what 4p2 looks like is 4 factorial over 4 minus 2 factorial. Okay? But don't worry about that quite yet.
Wait, can you say what the different
Like the 4 and 2? Okay? So the 4 represents the ones that we are choosing from, how many there are to choose from. The 2 represents how many we're picking from that number. Okay? So, would you agree that we found earlier that 4p2, choosing 2 letters from total of 4, was 4 times 3, which gave us 12? Would you agree with that? We found that in our first example, or second example. Okay? Now, mathematically, here's why that works. All right? 4p2 is written as 4 factorial over the difference of those 2 numbers factorial. So 4 factorial over 4 minus 2 factorial. When I write that out, 4 factorial over 2 factorial, what happens to my denominator? It cancels. This 2 cancels with this 2. This 1 cancels with this 1. So what's all that's left? 4 times 3, which is how we get to that number right there. Okay? So let's generalize this a little bit. The number of arrangements or permutations of n things when we choose k at a time will be written as n p k, which is n factorial over n minus k factorial. Okay, why do you think we divide out n minus k factorial? Why would we do that?
because it's like
Yeah, it's those leftover possibilities that we don't care about, right? So we got to get rid of them. So, for example, from that example, if I had 4 letters in a hat and I picked 2 of them, right? There's 2 letters still in the hat. Do I care how many different ways there are to arrange those 2 letters in the hat? No, I don't care about that. They can be arranged any way they want. Doesn't matter. That's why I have to divide out this bottom part. That divides out all that leftover stuff that we don't care about. Okay? It's all the arrangements of the ones we're not choosing. But we don't care about that, so we divide it out. Okay? All right, so if I want to express 10p4 in terms of factorial, I don't want a number. I just want it written as something factorial over something else factorial. Using your formula, would you please try and write that for me? Express 10p4 in terms of factorials. So what's going to go on top? 10 factorial. And what's going to go on bottom? How do we get 6 factorial? 10 minus 4 factorial. Okay? Now, go ahead and evaluate this. Go ahead and find this value for me. All right, what do we get? 50, 40. Good. Okay? All right, there is a way to go ahead and type 10p4 in your calculator. All right, first please type 10. Okay, then press the math button and arrow over where we were yesterday to get the factorial to PRB for probability. And then look at option 2 where it says NPR. Okay, see where it says NPR? Then we can put 4. We can do 10 NPR 4, and we should get 50, 40. Did you get it? Okay. All right. So would you please try 10P10? What do you think that's the same number as? It's the same as 10 factorial. Okay? What does that imply to us, looking back at your formula? If 10p10 is the same as 10 factorial, what does that imply about 0 factorial? Has to be 1. Okay? 0 has just all this weird stuff going on, right? It's anything to the 0 power, 1, even though that doesn't make any sense, right? 0 factorial is also 1. Just another one of those weird intricacies of 0. Okay? All right. I think the next one on your page is how many permutations are there of the letters X, Y, Z? Yes? Oh, well, don't write them all down. Tell me how many there are. 6. How do we get that? 3 factorial, 3 times 2 times 1. All right. The next one on your page. How many permutations are there of the letters P, Q, R, and S? How could I write this? I could do 4 factorial. What else could I do? Talking about this new thing we've just learned. No, in terms of permutations, in terms of that big capital P. 4p4. I'm choosing 4 letters from 4 letters. So 4p4 is the same as 4 factorial, and we get 24. All right? Try this next one. How many different arrangements are there of the letters in the word numbers? How many different arrangements are there of the word numbers? How do you think we're going to find that? 7 factorial or 7p7. Either way, what do we get? 50/40. All right? How many of those arrangements have B as the first letter? Okay, how'd you get 120? Not 5 factorial. 6 factorial. Because how many letters are left once you put B as the first letter? 6. So what is 6 factorial? 720. All right. How many have B as the second letter or the last letter or in any specified position? 720. Doesn't matter where it is, but it's a restriction in which we only have 6 other letters to arrange. So it'll still be 720. All right. I want you to take a second and I want you to try this one. How many will have N, U, and M together? And I want you to work it similar to how we did the Q and the E being together. So that's all the information you get.
Wait, I have a question.
Yes.
Is B still the first letter?
No.
Okay.
B is no longer the first letter. Okay? So take a sec, draw out your spaces, think about what goes where, give it a shot.